Okay. Hello, everyone. So let us start with our problem. So this question is pretty much simple. There are n sticks. So we are given n sticks of some particular length, and our task is to modify the sticks of each stick having the same length, right? So in our case, if you consider this example, here we have five number of sticks, right? We have five sticks, and we have to simply convert these five sticks into of five sticks which are having of same length, something like this: first stick, second stick, third stick, fourth stick, and a fifth stick. All these sticks are having of same length, right? So in order to convert these five sticks into this format, we are given an operation. Okay. You can either increase this stick size, or either we can decrease the stick size of any particular stick. Okay. So the cost of converting. So in our case, if you consider this, let us assume the length of each stick here is 4. Okay. And the cost of converting this first stick, which is having a height of 2, and we need to convert into a stick of height of 4. What is the cost of converting 2 to 4? Plus 2, right? And 3 to 4 is nothing but plus 1, like that. And if we keep on doing that, we will get some cost, right? And that cost, we need to reduce it. We need to reduce that cost. Okay. So in our case, our best minimized cost is 5. And let us see how we got 5 over there. Okay. So overall question is nothing but we need to simply make each stick of same length, and this length can be of any size. So let we don't know that particular length for now. So let us consider it as x, 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 and x. So we need to find this x value, and we need to calculate the difference. Now let us try to put our main focus on finding this x value and calculating the difference. So when you are in an interview, when an interviewer asks this question, you should not directly go for an optimal solution. First thing is you need to share the brute force solution. So what is the brute force solution for this? What is the brute force solution for this? So we don't know this x value, right? So what I will do, I will I will include myself that 2 is the best length. So what I will do, I will simply calculate. So the cost of converting 2 with 2 itself is nothing but 0. The cost of converting 3 to 2 is nothing but 1. And the cost of converting 1 to 2 is nothing but plus 2. And the cost of converting 2 with, sorry, this one is plus 1. And the cost of converting 5 to 2 is nothing but plus 3. And the cost of converting 2 with 2 itself is nothing but 0. So what is the overall cost that we got? The overall cost is nothing but 5 in our case. So you will do this for each and every stick. So if you choose x as 2, you got the result as 5. And if you choose x as 3, you might get lesser than 5 value, or you might get greater than 5 value. But you will store only if you got less than 5, right? And you will simply do this for each and every stick. So for each stick, we are simply iterating the entire array again. So the time complexity is nothing but n square. And what about space? Space is constant. Now, trying to come for solution 2. So since you already know that this question is on a topic of searching and sorting, now try to simply sort this data. Now try to simply sort this data. What did you observe from sorting the data? So I have already written the sorted data here. Now try to analyze and try to make some observations from this sorted data. So we need to simply pick an x value, find the difference for it, right? So let me just, I have three possibilities here. Okay. I have three possibilities. The first possibility is my x value can be 1, okay, which is the smallest one. And my x value can be 5, which is the largest stick. And neither small not large. I have my x value as 2. Okay. Now, if you consider your x value as small, what is the cost of converting the remaining? what is the overall cost of converting all sticks to the length of 1? 1 minus 1 will give you 0. The cost of converting 2 to 1 is 1, 1, and here you will get 2, and here you will get 4. What is the overall sum of converting to 1? So 4, 5, 6, 7, 8. We are getting 8 here, right? And what about 5? If I choose 5, here I will get 4, here I will get 3, here I will get 3 again, here I will get 2, here I will get 0. 4, 5, 6, 7, 8, 9, 10, 11, 12. Here I am getting 12. But if I choose the middle stick, neither large, neither small, but if I choose the middle stick, what is the overall cost that I am getting? So here I will get 1 plus 0 plus 0 plus I will get 1 here plus 3, which is nothing but 5. Now, if I choose x value as the smallest stick, I'm getting this one. And if I choose x value as the largest stick, I'm getting 12. But if I choose the middle value, I'm getting a reduced or a minimized cost between 8 and 12, isn't it? So what I will do, for each stick, I will simply pick the middle stick, or to put it in another words, for each stick, I will simply calculate the difference with the middle stick, right? If I do that, I'm getting the reduced reduced minimized cost. But the question is, why is this working? That is the important thing that we need to learn, not just the logic, right? Why is this working? So so to put it in graphical way, let us consider a chart. Okay, now assume we have 5 points. uh, let's say I have 1 point over here, 1 point over here, and 1 point over here, 1 point over here, 1 point over here. You know, I mean, this is the lowest value and this is the highest value, right? You all know that, right? Now, if I want to convert this value into the highest value, the cost will be definitely huge, right? The cost of converting from low to high will be definitely larger, right? So what I will do, instead of converting this low to high, I will choose a central point, which is this one. And the cost of converting the second point to fifth point will also be very huge. So what I will do, I will include a central point. And what I have done here, I will do the same thing for these nodes as well. I will convert this to this, and I will convert this to this, which will reduce the total cost. Okay. So this is not a more of a logic based question, but this is simply an observation based question. Okay. So if we go with this approach, what will be the overall time complexity? So the time complexity for first one is sorting the array, which will take n log n base 2 for sorting, right? And what else? And we need to simply iterate, just a second, and we need to simply iterate on the array again, which will take n time. But what about space? Since we are using med sort, it will be big of n space complexity, because for merging we need an extra array, right? So let us try to code it up. Okay, just give me a second. Okay, so I'm using this console. If you never mind. So first thing is we need to take the size of the array, and then we need to declare an array of size n, iterate on the array once, I plus plus, take the array input, and now sort the array. Array is equal to array plus n. Now what else? Now we need to find the middle element, which is array equal to n divided by 2, and iterate on the array again. For this, we need maybe long int cost. So cost plus is equal to nothing but array of I minus x. We have to take this in an absolute way. see out cost handle. Now let us simply try to use this test case. Comparison error. Okay. Yeah, my bad. We are getting 5 and it's anyway CSES. So downloads, ID8, submit, accept it. Now, if you see here, I have tried so many times. So this is basically another approach that I have done. So two cases are not working, but this is also a solution. So what I am doing here is I'm using a binary search approach. Okay. So you can have a look into this. Okay.